Hello everyone. This is the class for coordinate geometry. In this chapter, you have to read about the location of points in a plane. To represent a point in a plane, you need coordinates. Two coordinates are x-axis and y-axis. Distance of a point from y-axis is called x-coordinate or abscissa. Second point is distance of a point from x-axis is called y-coordinate or ordinate. It is written inside a bracket. First integer represents abscissa and second integer represents ordinates. Both these two integers are surrounded in a bracket. Third point is distance formula. Distance between two points, suppose A and B. How to find? The point which is in the left. Here, point A is towards the left and point B is towards the right. Conventionally, we take the point of left side as x1 and y1. The point at right side, we take it as x2 and y2. Now the formula becomes AB. AB means distance between point A and point B, or length of the line segment joining point A to point B. That it becomes root under x2 minus x1 whole square plus y2 minus y1 whole square. Here is few examples. First example is, there is a line segment with end points as A and B. Coordinates of point A are 2, 3 and coordinates of point B are 4, 1. Now we have to find the distance between A and B. Here, as students, you see here, point A is towards the left side and point B is towards the right side. We will take 2 as x1 and 3 as y1. On the other hand, 4 you have to take as x2 and 1 is your y2. AB equal to, here from the formula, x2 minus x1. Now, according to this example, you have to take the 4 minus 2 whole square plus, here is the place for y2 minus y1. You will take 1 minus 3 whole square. 4 minus 2 how much? Obviously 2. And 1 minus 3 how much? Obviously minus 2. You have to put a square on both these two integers. A square of 2 is 4. Again, we put here plus sign. A square of minus 2 is also 4. Now it becomes 4 plus 4, which is equal to 8. By prime factorization of 8, you will get 3 times 2. 2 to the 4, 4 to the 8. Now due to this square root, 1 2 will come out. third 2 will remain inside the root and you will have to write units. This is compulsory. If you don't write units, then your marks will be deducted. Now, students, this is second example, a line segment named AB. Coordinates of point A are -5, 7. Coordinates of point B are -1, -3. AB equal to, here you will get the formula. Formula is repeated here. AB equal to x2 minus x1 whole square plus y2 minus y1 whole square. Everything under the root. Now, as we discussed in example 1, the point which is towards the left, that is point A here, that will be considered x1 and y1. And coordinates of point B, which is towards the right side of the notebook, that will make x2 and y2. Here, according to the formula, x2 minus x1, that means minus 5. Students, here you will have to keep the concentration. Concentrate yourself. 3 times minus sign repeated here. First minus comes from here, -1. Second minus comes from the formula, that is here. Third minus comes from here, -5. Everything under bracket. Here you are getting 2 negative signs close by, so you have to use a small bracket to separate this minus sign from this minus sign. Plus sign from the formula, and y2 minus y1 will be replaced by -3 minus 7. 7 is positive integer, so here we will get only one minus sign. Now, solving these two negative signs when multiplied, it becomes positive. -1 plus 5 whole square plus -3 minus 7, that gives -10 whole square. 5 minus 1. 1 is negative and 5 is positive, and both will give the result positive 4. 4 square plus 100. 100 comes from here. Minus 10 square, that is 100. 4 square 16 plus 100, 116. By prime factorization of 116, we get 2 into 2 into 29. 2 is repeated here 2 times. So 1 2 comes out of the root, and 29 being single remains inside the roots. And you have to write units. Second example is completed. Example third. Here is the key. Maximum students are very comfortable with numbers, but very uncomfortable with alphabets. If you get alphabets in place of numbers, how will you deal with them? Here, coordinates of point A are A and B. Coordinates of point B are -A and -B. These 4 alphabets replaced the numbers. Now, length of line segment AB, you have to use the same formula, that is x2 minus x1 whole square plus y2 minus y1 whole square. x2 minus x1. x2 minus x1 will be replaced by minus a. This will come in place of x2 and this positive a will come in place of x1. Minus sign between them will come from formula. Similarly, in place of y2 you have to keep minus b, and in place of y1 you have to keep this positive b. This minus sign comes from formula. Minus a, that becomes minus 2a, plus sign from the above. Minus b, that becomes minus 2b. Squaring these things we get 4a square plus 4b square. Taking 4 common we get 4 into a square plus b square. Square root of 4 is 2, so 2 comes out of the root, and inside the root we get a square plus b square, and at last you have to write units. Some students feel difficulty here. They think if it is a square, that means a into a, this is b square, that means b into b. Then why not we take out single a and single b from the root? Be careful. This plus sign stops us in doing so. If in bracket you get a plus b, then whole square. Square, I repeat, a square above the bracket. Look here, a plus b whole square. If you get things like this, then this means a plus b into a plus b under root. Then you can take out one set of a plus b. You can take out of the root. But if squares are indivisible, squares are not like this, then you cannot take out a plus b. I hope I made it clear. You have to give 2 minutes here to stop and think the basic difference between this and this. Here you get a square plus b square, but here you get a plus b whole square. If it is whole square, then it will be written like this, and one set of a plus b will come out of the root. But if a square is not written as whole square, squares are indivisible on a and on b, and you get any positive or negative sign between a square and b square, then never bring a b out of the root. You have to write it like this.